Welcome, everyone. It's so great to see the Equitech Futures community show up. And I'm really excited to spend the next 30 minutes or so with you talking about some ideas I've been thinking about over the past 6 months or so. This builds on a number of ideas that we have covered in our institutes, including the Civic Tech Institute, the Equitech Scholars Program, and the Applied Data Institute. The topic of this masterclass is to figure out how to think beyond the hype of generative AI technologies that you probably hear about day in, day out. When we started Equitech Futures in 2020, AI was kind of a niche topic. People in computer science were interested in it. There were some technologists who recognized the power. I think it's fair to say that in the last 4 to 5 years, it has become a household topic of interest, dread, depending on how you see it. And there's a lot of noise around what generative AI can and cannot do. So I thought it might be a great idea for us to reflect a little bit on the potential and pitfalls of this new wave of generative AI and how it fits into the evolution of AI over the past 75 years. And I want to begin with this article from the New Yorker, which was a profile of Geoffrey Hinton, who won the Nobel Prize this year, and was kind of one of the early fathers of artificial intelligence, the generative artificial intelligence revolution. And he has kind of gained a lot of notoriety recently about why he's alarmed about the rise of artificial intelligence, the way in which we see it. He has, really pointed to the dangers of AI. He resigned from Google, I believe, a few years back. When you have someone who's very senior in the field, is one of the creators of the field, raise an alarm about a new technology, it's worth paying attention, but it's also being a little skeptical and trying to understand why he is worried about it and whether his fears are warranted. And while people seem to be very worried about AI, the reality is a little more complicated, right? When Google's Gemini came up with its version of AI, you saw the kind of jokes being spread out, which was a little bit like you asked a question like, how many rocks should I eat? And it very confidently answers at least one small rock per day. Turns out that's because Gemini was training itself on the corpus of text from everywhere on the internet, including The Onion, which is a satirical magazine. And it had this article which said geologists recommend eating at least one small rock per day. And AI isn't really quite able to distinguish satire from reality. So when you see things like this, you sometimes wonder if people like Hinton are being a little too hysterical about the risks of AI. I think, by the way, that the reality is somewhere in between. I think there are legitimate risks from this new technology, but I don't think that we are going to see the kind of Terminator-style scenarios anytime soon. Although I know this is going to be a public recording, I might have to eat my words in a few years. So I'm just going to put a huge asterisk on that and move on. I think the concerns about how AI is going to impact the real world has also kind of spilled out of the technological community into the policy community, into governments. There was a report by the International Monetary Fund last year, which said that nearly 40% of global employment would be disrupted by AI. There is already a crisis of employment around the world, and this is, pre-AI. AI, is deployed in a lot of places, but the deployment isn't widespread yet. And so this is really alarming. If IMF says that 40% of global employment could be disrupted by AI, we should be seriously thinking about how we reform education systems, how we upskill people, really think deeply about the kind of investments we should be making in the next generation of companies. And this is a serious policy issue that I think has been in the minds of almost every major policymaker over the past year. Um, while at the same time, there's also a lot of skepticism about whether AI is really giving us the kind of output that people thought it would. This is an article from The Economist from this year, which basically says, whatever happened to this AI revolution, so far the technology has had almost no economic impact. I should mention here that most technologies take a decade or beyond a decade to really have the kind of widespread economic impact. I think we saw that with the internet, with things like digital finance. And so I think it's a little too premature to expect that AI will have an economic impact. We will see that. I believe that it will have real economic impact, but it's going to take some time. So given this context and this kind of debate in the public sphere about what the role of AI is going to be in society in the next decade or next 2 decades, it's worth asking, what are some mental models to think about the practical impacts of generative AI? And I want to pose this question to the group here, just to kind of get a polling of where you see the pulse of AI in your lives. And I'm wondering if you can speak up a little bit about what you think might be practical ways in which AI might affect your area of expertise. I know there are people from public health, from policy, from computer science, economics here. So I'm curious to hear about what you think might be some impacts. And hopefully we can figure out how that changes over the duration of this class. I'm maybe looking at Apollinaire right now.
In my current work, I'm a data analyst, and I do use AI definitely to help me, with my day-to-day coding. And I do not specifically feel like in the next few years I'm gonna be like, affected in a bad way by AI, simply because, as you said, that it might take time before we see economic, outcomes of it. But I think it might take time before people in my field, especially, trust the output of AI very well, in the sense that they will really assign an entire data analysis codes to the AI. As in, when I code with AI, most of the time I don't even trust the output at the first sight, right? So I feel like it's gonna take so much time before we reach that phase. And at this point, while it is where it is right now, I just feel safe about it, and I use it in the limited capacity I want.
That's a great take. So you use it in limited capacity, but you don't 100% trust the outputs. So unclear as to what the kind of long-term impacts of this might be. I'm going to get one more voice here. Leila, I would love to hear from you.
Hi. So I was thinking in the humanitarian realm and social action where I work. So, for example, now we are probably not, of course, not fully relying on an AI, but it's definitely been helpful when developing training materials or trying to reach groups that before we wouldn't have the capacity to. Also to streamline processes, facilitate reporting, and yeah, but as already mentioned, always with a critical view behind it and being aware, of course, of its flaws.
Yeah, this is especially in the social sector, in governments, one of the problems that one hears all the time is the amount of bureaucracy that might be involved, the amount of paperwork that might be involved, and AI has a real potential in making those processes efficient. And if it can do those tasks reliably, you can imagine the impact of AI to be quite profound in governments and in the social sector, where human capabilities and just human resources are relatively limited. And we'll talk more about that. But these are two excellent examples. One from sort of the data analyst academic sector, and the other from the social or the government sector.
If I just
Yeah,
add
please
a
go ahead.
vocabulary. Yes, and one area of concern in humanitarian affairs is an automated decision making, which of course brings governments and the public sector all along. This process is being automated and maybe losing a bit of the human view on them. And as we can see, of course, training data can be historical, can be biased as well. So that's an area of concern. So yes, enabling processes to be faster, decisions to be made quicker, but the human eye might be increasingly missing.
Yeah, and I think sometimes we forget the fact that in governments, especially in any form of collective action, right, whether you have governments or companies, the accountability around decisions is important. And as Leila mentioned, when you have a lot of decisions that are automated using AI, the question obviously becomes, who's accountable for this? Is it the algorithm developer? Is it the person who's using it? And even when it comes to the algorithm developer, is this just a product of the training data set that was used? Is it because it was not audited accurately? These are the kind of problems that I think are going to become front and center of the deployment of AI in the real world. There's a lot of conversation obviously around how AI gets built, and there are lots of engineers trying to build that. What I think is interesting about the AI revolution is that it's going to touch upon almost practically every sector that you might be working in, which means that you really need to develop that critical ability to think about where you can use it, where it might be risky to use AI, and how you make the judgment about whether or not to use AI in a given context. So thank you so much for that, Leila. In the historical context, if you want to kind of see AI in three ways, I would argue that AI probably started in the 1950s with Alan Turing and Cambridge, and then for the first 50 years, the idea behind how intelligence worked was this rules-based AI, where you basically would code in a bunch of rules into a machine, and as long as you had ample amount of computing power, you would be able to accomplish more complex tasks. So we saw an evolution of how chess improved, the performance of machines in playing chess improved from the 1960s to the 1990s. And this is an image from Garry Kasparov, who had a match against Deep Blue, and this was an example of an AI, a rules-based AI, Deep Blue, defeating a world champion. Now, chess is a difficult game for most humans. I don't know about you, but I definitely I'm terrible at chess. And so most people thought, well, if machines can do really well at chess, obviously other things would be quite straightforward. That was not true even for simple things like image recognition. When people tried to write a bunch of rules for identifying, for instance, how to distinguish between a cat and a dog, you can start seeing that it becomes fairly impossible fairly quickly to be able to write down a set of rules explicitly. So this rules-based AI did not really apply to a number of things that we as humans do quite easily, like recognizing images or sounds and sentiments in texts. So the early part of the 21st century, the kind of real innovation was to move away from the rules-based approach to AI to really thinking about a learning-based approach to AI, which was to mimic how the human mind learns how to recognize the world, which is to look at examples and then learn based on those examples. Now, of course, I'm being a little facetious here when I say how the human mind works. Of course, if you show a child 2 to 3 images of cats, they're able to extrapolate quite easily what other cats look like. In the case of machines, you would need hundreds of thousands, if not millions, of images for machines to be really able to distinguish between a person and an animal and an object and so forth. But the fact that the internet really boomed in the early part of the 21st century led to just vast amounts of data being stored and eventually labeled. And that led to this wave of learning-based AI that made computer vision possible, sentiment analysis possible. And that led to the wave of learning-based AI and in the first 15 to 20 years of the century. What we are seeing in the past 5 years is the third wave of AI, which is what folks have been calling generative AI, where the goal is not just identifying images or trying to figure out the sentiment of a text, but to really be able to create new text, create new code and images and video. And of course, all of you are familiar with tools like DALL-E and GitHub Copilot and Claude, and likely use it in a day-to-day level. But the question really is, how is this latest wave of AI going to be impacting the way in which we do things at a day-to-day level? And how is it distinct from the supervised learning era, the learning-based era that we saw in the first 20 years? So in supervised learning, which is learning-based AI, we saw the framework was fairly straightforward. We basically had access to lots and lots of training data, which had a very specific format. You had an input and a label, and you have a training algorithm that is able to find the patterns in the input data and the label. And then you have a predictor algorithm, which can take an input and make a prediction for the label based on what it has learned from the training data. So the way in which supervised learning worked was basically you wanted to be able to predict what the label would be for an input with an unknown label. So I show you lots and lots of pictures of dogs, and I've labeled them as dogs. So once I show you the image of a dog, the question really is, how do you figure out what the image is? Generative AI is different in that it's the inverse problem. What generative AI does is look at, again, a lot of training data with things like inputs and label pairings, but then ask the question, given a label, what is potentially the input? So suppose I tell you, create a picture of a dog. Instead of in the learning-based scenario where you were learning that different images corresponded to a label that was a dog, here, having seen a lot of training data, you are asked to create the picture of a dog. So you want to design algorithms that want to create the picture of a dog. I want to stop here and reflect a little bit about what you think might happen in this context. How might this inverse problem be different from the way in which supervised learning worked? And I'm curious to hear from Zaina and then Clinton.
In the first case scenario, we have where we're having a predictive output. We're taking data in and putting it out. Now the AI is being prompted to actually generate something, and it's got, in a sense, it's kind of got to take information from somewhere and then create a new type of output in this sense. Whereas in the other model, we kind of already had the data. Now it's being saying from all of this, create something from that. Whereas in the past or on last model, the material was already there.
Yeah, so I want to flag here that the generative AI still depends on the training data. So you still have a lot of the training data around, but as opposed to the earlier case where you were predicting a label, here you have to predict an image. You basically have to, given a label, I have to predict what a set of pixels in an image might look like. Clinton, would you want to add to this?
Yeah, so I think you've explained it quite well that in supervised learning, sort of, you have like this lots and lots of images, and basically the whole idea is to see a lot of the features. Okay, I'm doing I did image analysis the semester I'm doing my master's, and one of the things that we use to for example, constructing a network is what we call feature maps. And so in these feature maps, basically, you have sort of all these different aspects of an image being represented by each feature map, right? So if you say there's an eye represented by this feature map, there's like probably facial layers in a cat or a dog represented by a certain feature map. And sort of that is passed on and learned. And then what we have at the end is, okay, these are a dog will look like, and these are a cat will look like, and these are the different differences. But also you just need to have enough so that you don't overfit. You don't be like, yeah, we have so much and we just need enough to make sure that we distinguish and make sure that we actually label this correctly. But I think what Gen AI has done is that it has all this data that is available to it. And I mean, this could be collected anywhere on the internet, Reddit, and all these places. And basically it says, from what we've gathered from the internet, these are the images of dogs. And this is how a dog looks like. So if you ask me for an image of a dog, this is what I'll give you as the output. So yeah.
Yeah, so the general theme here seems to be that in the classic learning scenario, you would basically have a set of pixels that would correspond to a single label, say a dog or a cat. And in this situation, you have a single label that's going to, and you have to predict a matrix. You have to predict a set of pixels that would correspond to an image. And as you can imagine, that can be, that can have quite different properties. And so and in fact, one of the things that happens in the case of inverse problems is that they tend to be non-unique. And we know that from the way in which functions work. So you could have a function and the function would be non-unique. So for instance, if I write down or if I prompt Claude to say, write a poem celebrating Equitech Futures, I can give the exact same prompt. But if I do that, literally a minute after I have prompted it, it'll give me completely different poems here. So the first kind of characteristic of generative AI is that it is non-unique. And that's distinct from the way in which the learning approach to artificial intelligence worked. So remember in supervised learning, you still would not get 100% certainty for a particular label. It would tell you that, the label is likely a dog or a cat at 90% or 95% accuracy or certainty. But the difference in Gen AI is not about the percentage accuracy, but fundamentally non-uniqueness of the output. And I think that's the distinct shift between the learning approach to the generative AI approach. The second is the fact that generative AI outputs are highly unstable. My nephew really likes slots, and so I was playing with DALL-E with him, and he said, giant steam train with hundreds of slots and cars waving at the outside world, and you can see DALL-E comes up with a really cool image, and it's really fun to be able to play with children to create these images. Like a graphic designer would have taken multiple weeks to come up with this. The output here was generated in seconds. really amazing. But you also have a situation where you ask AI to generate the image of a person, and you see just from the eyes, like, it's completely a little weird, like it's looking unlike the image of a person. So it's highly unstable in that. And by instability, I mean that if there are small noise in the training data, the small noise can get amplified quite quickly. So the output of a lot of these generative AI tools tend to be not very stable, which means that it's very sensitive to the data sets. And so you might then wonder, like, is this just then a fun toy? Is this just meant to be for, making pictures of slots and trains, or does this really have any economic value? And I think that's a very legitimate question to ask. If you think about what generative AI is good at, it's good at creation, generating long-form text, code, images. It's good at reasoning to a certain extent. It's still not there. Executing multi-step processes using reasoning. This is where things like automation. You can have lots of complex processes be automated if you have reasoning happen in a consistent way. And then it's also able to parse very complex documents, summarizing long texts. So if you think about, I was talking to a group of hedge funders recently, and in hedge funds, the bulk of the time is spent in analyzing very large texts, right? So people will read reports, financial reports, and what happens is the vast majority of time that is being spent by a lot of people in the hedge fund industry is reading and trying to summarize complex documents. You can imagine tools like generative AI can help make that process a lot more seamless. A lot of you are coders and have generate a lot of code, and I think all of us would agree that if we had some kind of a personal tutor for coding, our coding would become much more efficient, faster, more accurate. And a lot of AI tools are honestly quite good. I was trying to get ChatGPT to generate code for generating a map that was or generating a plot that was that's something that most first-year graduate students in an astrophysics course would do. And when I ask it, I ask the give it the right prompt, it generates a pretty accurate piece of code. And I wish that when I was in grad school, I had these tools to be able to play around or learn from more efficiently. So really, I think lots and lots of opportunity for making a lot of processes faster. Here's another case study for how large language models or generative AI models could be used. This was from a paper where folks gave a customer persona to ChatGPT and said, design a business plan based on the customer persona and the activity. So, for instance, in this case, the customer is supposed to be parents of young children who want to dress their kids in trendy, comfortable clothing made from safe, eco-friendly materials. They value convenience and often shop online. The product or service is an online boutique for children's wear, focusing on trendy jeans. And the main activities that it gives are selecting eco-friendly children's wear, maintaining an online boutique, managing a subscription service, etc. And it fleshes out the business model quite well. You can imagine that for a small business owner or for an MBA student who's trying to figure out, okay, what might be different businesses that one might want to invest in or one might want to build. This can be an interesting tool to play around with and just generate lots of ideas. And the way in which those strategies came up is you basically give the system a a prompt which says, you're a founder of a startup active in a particular industry, and then you give the industry description. Your task is to propose 3 business models for the startup. Each business model should have 125 words, focus on a single customer group, differ from other 2 business models, et cetera, et cetera. And you kind of get the business model description as a result of this. So really interesting to come up with new ideas. Here's another example of using large language models in strategy. This was a study by BCG, the Boston Consulting Group, and Harvard Business School, where they gave GPT-4 access to about 700 consultants at BCG and tracked how consultants performed in tasks that is typically seen in the consulting industry. And you sort of see that, there's some people, especially at the top of the productivity frontier, who really use it effectively. People who, are not as good at kind of, base level consulting tasks. The output is still kind of, debatable as to how effective it really is. And so I think, thinking a little bit about who AI benefits is also equally important. This is quite distinct, again, from the way in which we think about regular computing, where the automation or the automation due to computing might lead to automation and might lead to efficiency increases across the board, whereas in the case of AI, the interaction with the human is equally important in achieving efficiency than the technology itself, which makes it a little more complicated in deployment. What are some, this is great news for business consultants, the finance industry, but what might be some pitfalls? Here's an example where lawyers used ChatGPT to save some time, and it turned out that ChatGPT was basically generated a lot of cases that just never existed, and that led to the lawyers getting fired. This kind of, these are called hallucinations. Hallucinations are examples of either references or cases and things that don't exist that ChatGPT just makes up, which, by the way, is related to the non-uniqueness of the inverse problems of generative AI, and that leads to hallucinations, which again make the technology non-trustworthy, right? If AI hallucinates, it's unlikely that a lot of lawyers or other people might use it. So this is really a problem that I think is at the forefront of deployment, right? Deployment concerns about how effectively this can be deployed. Another example of hallucinations, Air Canada had ordered, or Air Canada was using a chatbot which made up a case, it made up an offer for a customer, and then that offer just did not exist. And then the customer sued Air Canada, saying, Air Canada was supposed to hold up to that particular offer that was made up. So I want to begin and kind of talk a little bit about where I see the generative AI value chain is going to be. We have been talking about models a lot, the kind of base large language models like ChatGPT, Claude, but the real value of generative AI is again going to come from the types of data lakes that institutions or individuals have access to. So if you are a financial company, the access to different types of research reports or interviews that you have access to is going to be the moat or the value that you can really generate. Models are just starting to become relatively cheap. People sort of say, this is we are approaching an era where intelligence becomes too cheap to meter. I know that's a fancy way of saying models are becoming cheaper. But data lakes are still, creating data lakes is still going to be quite expensive and valuable, and that's where a lot of value is going to be created. And the other end of the value chain is decision makers. What output you get when you have models and data lakes interacting with each other. The eventual value will come from humans making decisions. And so poor decision makers are going to give you low value even when you have high quality data and models, whereas high quality decision makers, human decision makers, can really leverage these proprietary data sets and models to add a lot of value to whatever enterprise you are doing this, whether you're doing this in the private sector or in government, etc. So this kind of like really highlights the importance of thinking about novel data sets and how we should be training the next generation of decision makers who can leverage models and data lakes to be able to create value in different domains. Before ending, I just want to kind of summarize some of the issues that we see in deterministic in generative AI versus previous models or previous waves of computing. I like to think about it as deterministic versus stochastic computing. Generative AI systems are stochastic in that they're not going to give you the same response in different instances. And this is a clear departure from earlier models of computing, which were deterministic. If you had a calculator and you put in, 4 plus 4, you would get 8. And that was your mental model for using a calculator, right? You did not have to constantly worry about whether you needed to double check the work of the calculator. Whereas you have to always worry about, how to double check the work of a generative AI tool. And that just makes it a fundamental departure from earlier waves of computing. Stochastic computing can lead to a whole new explosion of new use cases. Think about new creative tools, new ways to write, analyze data, but requires actually greater human steering and oversight. So this perspective we have that generative AI is just going to be able to automate a lot of tasks, I think is a little misguided, because I think it's going to be able to automate tasks with human steering and oversight. And I think that's the next challenge that applied AI practitioners will have to figure out. How do you design generative AI tools where human steering and oversight is robust? And the applications of these tools does not lead to adverse outcomes. The other thing to keep in mind is I don't think that any of your jobs are at great risk. AI will transform tasks. It's going to make a lot of tasks more efficient. It's not going to take away jobs. It will take, I should add here that it will take away jobs in the sense that things that require 20 people in the past will probably require 2 people. So I think it's just going to make a lot of systems more efficient. What the implications are for that for industry, for the social sector, I think we are yet to find that out. I think we are really on, the recent freezes in the tech sector, where a lot of companies are basically saying, hey, we don't need to hire new people because AI is making things efficient. We don't know how much of that is really because of AI or because tech companies really hired a lot during the pandemic. We'll figure that out in the next couple of years. But I think these are conversations that are already starting to happen. I think it is true that we're going to likely to see productivity increases across a lot of industries where paperwork, bureaucracy is quite intense. So I always think about the finance industry as an example. And the final thing that I would say is that it's worthwhile thinking about AI as cognitive infrastructure rather than a consumer product, the way in which we thought about Facebook or the way in which we thought about the kind of app economy in the previous era. So with that, I just want to thank you all for joining, and I will take any questions.
No questions, Abhilash. I think it was very clear. I was just thinking of your last sentence, or one of the last sentences of you're encouraging us to think of AI as cognitive infrastructure instead of consumer. Can you elaborate a bit more on that as a final note?
Yeah, so I would say the way to think about the previous generation of computing tasks, where you basically gave a certain set of instructions, and you were able to get an output from that set of instructions, right? Whether that is saying, going on Amazon and saying, hey, I need a particular type of grocery, get it delivered, and that was the kind of step-by-step process in the app-based infrastructure. In the case of cognitive infrastructure, I think it is very dependent on what kind of prompting that you give it, right? So you can, I can imagine making, I like to think about it as sort of saying, you have a very smart, but at the same time, a very smart intern who needs a lot of instructions or needs very careful instructions, right? So in the case of Amazon, or the previous app-based economy or app-based infrastructure, you did not need the quality of instructions that humans gave to the machines to be that relevant. Now, in the case of cognitive infrastructure, the quality of instructions that you give it becomes increasingly relevant. So if I'm wanting to write a poem, I can say write a poem about a dog, or I can say write a poem in the style of Raina Rilke, on a seaside. And I think the quality of poems that you will get from both the outputs are going to be just profoundly different. And which is what I mean by cognitive infrastructure, where the role of the human actually becomes even more intense, which is kind of counterintuitive to what people think about a lot of generative AI, thinking generative AI is going to replace humans. But actually, it's the opposite, where generative AI actually requires a lot more human steering, and the quality of outputs that you get requires a lot more human steering.
So as takeaways, that prompt engineering and critical thinking are to build a solid
critical thinking is even more important than ever, especially when you are engaging with the outputs, because you cannot blindly believe the outputs, right? And there's something that I tell the students all the time. You always check the work that your intern has done. So always think about AI as an intern, and always check the work before you deploy.
Thank you.
You're welcome. Ronnie, Pranati, and then Zena.
Yes, good evening, and I don't know, maybe good afternoon or good morning from wherever. Thanks, Abhilash, for this. And my concern is kind of related to concerns raised by Leila as well, especially in education. Traditionally, it's been much more focused on innate abilities, those inborn abilities. But then now we are increasingly seeing AI being used in education, in different sectors, in medicine, or even social sciences. So my question would be, how then do we balance these innate human cognitive abilities and the abilities and efficiencies presented by AI?
Yeah, that's a great question. Sorry, go ahead.
Do we need to worry that in a few years' time, then the AI will increase our efficiency, but might also affect negatively our cognitive ability?
In some ways, I think it is likely to affect our cognitive abilities. We just don't know how. So I'll give you an example. I don't know if this was a part of your education growing up, but when I was growing up, we had to remember multiplication tables from 1 to 15 or whatever. I don't think anyone teaches people to remember multiplication tables these days. You have access to a computer. No one really remembers the multiplication tables. And so Now, I mean, is that a cognitive barrier? Yes, in some ways that, people, if you ask someone on the street without an access to a calculator to make a, complex estimation, they're unlikely to be able to make it. Is that going to really affect a person's like day-to-day activities? Unlikely, given that they have access to a calculator or they have access to a computer or a phone. And so I think in a similar way, I think access to AI is just going to make certain types of cognitive tasks that we have a lot more kind of seamless and things that we would spending a lot of energy a lot more efficient. But what that leads to in the long run in terms of human cognitive ability, I don't know is the answer. Like I think that we need to be open-minded and really experiment carefully in terms of deploying these tools. And again, like, we should really approach this new technology as thinking about a new tool that we learn by experimenting and then figuring out when it is working, when it is not working, as opposed to just, blindly believing that it is going to be useful everywhere. I think it's going to be really useful in certain cases. It's not going to be very useful in others. And figuring out where its utility really lies has to be done empirically by just running experiments and seeing, is it really leading to better learning outcomes in students? Is it really leading to making healthcare decisions more efficient? I think we just don't have the evidence at this point yet. Pranati.
Hi, Abhilash. Good evening, all. So on your presentation on pitfalls of, generative AI, I just recently read an article about how Gemini got its tool wrong, where it, basically portrayed historical misrepresentation. Um, and how on one side we say that there are potential, bias in algorithms. On the other end, we also say that the algorithm can technically whitewash history or completely misrepresent history. So how do you see, where is the balance between creating the right kind of training data sets, and where do you think maybe Google went wrong in approaching this?
Yeah, this is a huge question, which I think has to be split into. So when we're thinking about generative AI, we have to think about two distinct processes. One is the training using the training data, and then what's called post-training, where you take the outputs of a base model and you figure out that it is aligned with certain human values, and there's and the process through which that happens is what's called reinforcement learning using human feedback, where you basically get a bunch of outputs from your kind of base model and you say this is acceptable, this is not acceptable, and you do that over a wide area or a wide number of examples to effectively, it's a little bit like teaching your dog to behave in some ways, right? So you're literally teaching the model how to behave in a certain way. Now, there are challenges around what kind of data sets you're using for your generative AI based model. So if you're using, say, unvetted Reddit posts, you're going to get a lot of outputs that are, spewing out output that's hateful content, misogynist. I think that is something that happened in the first example of this Twitter bot that Microsoft had designed, where they had used a bunch of Reddit posts, and then the Twitter bot started, spewing terrible racist garbage in few hours of it being deployed. And I think that's a training data problem. The second problem, which is I think the bigger challenge, is how you conduct reinforcement learning using human feedback. And the problem in Gemini was that the reinforcement learning using human feedback was just not, it appears as if, I mean, I obviously don't know how that occurred in the company, but my guess is that that process of post-training was done poorly and should have, and even after having done poorly, I think the probably the cardinal sin with Google there was the fact that they did not test it before deploying it, right? You really want to have your model undergo very rigorous testing before deploying it. That is something that, was I think a flaw that they had. Zena.
Thank you. And also thank you to everyone who's asked questions. I really enjoyed hearing some of the questions kind of filtered into some of my own questions about what I wanted to ask, which is kind of piggybacking off what the last two speakers said. We talked a little bit about the importance of how and who is using these models. Particularly my question relates in kind of like a two-pronged effort of, is it now more important than ever that the data that we're giving these models be tried, true, and tested? And the second part is who's overseeing these models. We talked a little bit about what would happen if an individual was basically an overactive intern, but what happens if the people who aren't using these models aren't experts? So what do we do in these instances? We talk about critical thinking skills and how that's important, but now how do we build that for someone who's constantly using that and may not be an expert person to have that expert mindset of already being in the industry saying, hey, I already know that this is not right because I'm the expert. But what happens when you get a student who probably couldn't tell you any better? And those are my two.
Yeah, that's a great question. I think requires a understanding or requires a cooperation on two fronts, right? So one is deployment of AI applications in high stakes settings, and high stakes includes education, healthcare, where you really want to make sure that any tool that you're developing and deploying has been robustly tested and rigorously tested before it gets deployed. And I think blindly, taking ChatGPT and deploying that in the classroom, I'm not quite sure if that's the best way to proceed. On the other end, I think it's also it has become increasingly important to figure out how to train people to be good users of AI, right? I think there was this whole conversation about the digital divide in the first 20 years of the century, which was about first was obviously access to technology, which was like, do you have access to a computer or do you have access to internet? But the second was, can you use it? Do you know how to effectively use a computer even when you have access to it? And I think we have a similar conversation coming up around AI. I think these tools are available quite easily to a lot of people. Like, if you actually go on WhatsApp, WhatsApp has an embedded large language model where you can interact with it. And so these technologies are now available for free for literally billions of people. The question now is, how do you train billions of people who have access to these technologies, who we know don't have very good training in basic literacy, training in basic numeracy, to be using these tools. So the gap between the kind of educational outcomes that policymakers have been talking to us about for the past 20 years and the access to these technologies that requires a base level of cognitive kind of capabilities, I think is quite large, and I think that is going to be a central problem in the usage of these technologies. Like, how do you train billions of people to use this technology in effective, safe ways? I honestly don't know the answer. I mean, I think you all other folks who are going to figure out how that will happen in different contexts, whether that is in education or healthcare or in public policy. And also this needs to be sort of locally driven initiatives, right? I mean, this needs to be how you train individuals in Togo to learn AI better looks very different than how you train someone in Chicago to use AI better. And so I think, if anything, this is just going to lead to a very interesting new type of digital divide that needs to be actively worked on.